All right, here's a nice little integral. Um, so we have a square root on the bottom and also an x squared. So the square root on the bottom looks like a squared minus u squared, which is a great arc sine candidate. However, as you probably noticed, we had this x squared here, and that's going to screw everything up. If this wasn't there, that's an arc sine pretty easy. But this is there, so we're going to have to try to find another method. So this is a really interesting method. You can use your Pythagorean identities to actually do the square root, because the square root's really the issue here. This is called trigonometric substitution. And when you have a difference of squares or even a sum of squares, you can make use of the simple Pythagorean identity, sine squared plus cosine squared equals 1. From that, you also get, if you divide by sine squared, you get 1 plus cotangent squared equals 1 over sine is cosecant squared. You can use that one. Sometimes you will have to do that if there's maybe a plus instead of a minus, or you could divide by cosine squared. So you just have to think about which one. So if I hold on a second, let me finish my divide by cosine squared. So these are the three basic Pythagorean identities. There's only really one Pythagorean identity. The others are just simple variations. But if you can use these to be able to eliminate the square root, and oftentimes you can, that would be nice. So I would like to eliminate the square root. I'd like to make this a one single term square, and I have a 25 minus x squared here. So as you can see on the one I circled, sine squared equals 1 minus cosine squared. So I'm going to, what should I say? How about this? If we could make this 25 minus 25 cosine squared, we have it. In other words, if I said that, then this square root would just be 25 sine squared, and I could square root it. So we have to figure out a way to do that. Well, if you let u be 5 cosine, that would make u x. I'm sorry, I shouldn't even say u, it's an x, isn't it? So hold on a second. There's a screw up there. I'll fix that. If you let x be 5 cosine squared, and sorry about that, horrible. If you let x be 5 cosine theta, then x squared would be 25 cosine squared theta, and I already had that 25, that's why I chose it. Then this whole thing would be 25 sine squared, and I could square root that. So that is something that might work. So I'm going to go with it and see if it does. So from here, this has just become a u substitution problem. It's actually an x substitution problem. So if I'm going to let x be 5 cosine theta, and if you didn't see this, by the way, pause the video and think about it. So I'm going to, if x is that, dx is then the derivative of cosine is sine times d theta, and I'll have to make all these substitutions. So here we go. We have 5 is the constant. I can, well, no, I might need that. I have dx up here, which is negative 5 sine theta. So let me just negative 25 sine theta d theta. So as you can see, I just took care of the dx, straight substitution. Square root of 25 minus x squared is the square root of 25 minus 25 cosine squared over here, which is the same thing as, which we said over here, 25 sine squared theta. That's great because I'm going to be able to square root this. And the x squared, well, we have x here. So the x squared is just, hold on a second. Let me fix this. I'm not a very good planner. The x is 5 cosine theta right here, and we're going to square that. All right, so now we have this complete mess. Let's start simplifying. That's going to be 25 cosine squared theta. The square root of 25 sine squared theta is 5 sine theta. Now we're going to start canceling things out, and this looks really good. The 25s will cancel. We're left with a 1/5 on the bottom. The sines cancel too, so that's really good. We're just left with 1 over cosine squared. All right, so if we could integrate this, that would be fantastic. And we can. Cosine squared, or 1 over cosine squared is secant squared. Perfect, because we know that the integral of secant squared is tangent. So we've completed the integration. That is great. And as you were hopefully yelling at the screen, I forgot my negative sign. But now it's fixed. All right, so now here's the thing. I can't say that this integral is tan theta because that doesn't make any sense. So now you have to substitute for tan theta. You'll notice I don't have a tan theta. But I do have this. So we know x. So this is a normal process in this type of problem. X equals 5 cosine theta. The easiest way to accomplish this is with quick trig. That means cosine theta is x over 5. And let's go to our tried and true right triangle. So theta is the angle. Cosine is adjacent over hypotenuse. Pythagorean theorem will say that x squared plus this squared equals 25. So this side would be 25 minus x squared. So that means the tangent of theta is opposite over adjacent. So now we have completed our back substitution. It's just like plugging u back in. This is just u substitution, but with a trig spin to it. And I like that. I think we're all simplified. Maybe I'll just go negative root 25 minus x squared over 5x. I'm pretty satisfied with that. That wasn't too bad. It's just a new technique. sure some of you will disagree with me as far as the level of difficulty, but there you go. Let's check it with from alpha, and it looks excellent. So it worked. See you next time.